Welcome back to The Deep Dive, the show that takes your stack of sources and transforms them into actionable knowledge. We all have to navigate uncertainty every single day. I mean, whether you're leading a major software launch, planning a complex project, or, just trying to get through a week with shifting requirements, the difference between success and, well, chaos often comes down to one thing: anticipation.
That's so right. And today we are taking a deep dive into exactly that, the discipline of anticipating the future.
We're focusing on two core pillars: risk management and dependency mapping. Our sources for this are really a combination of two powerful worlds. We've got the systematic, globally recognized
Standard from the Project Management Institute, or PMI, and we're combining that with the, let's say, hyper-practical framework from the Silicon Valley Product Group.
Okay, so our mission today is to give you a really solid understanding of uncertainty, show you the specific tools that professional teams use to manage it, and then, and this is the important part, connect those dots. Because as we'll see, a project's biggest risk is often a dependency you didn't even know you had.
Exactly. We want to take you from the abstract definitions all the way to practical application. It's all about how successful teams identify uncertainty, assign clear ownership, and then actively, mitigate it.
So let's kick things off with the most fundamental definition. We all use the word risk pretty casually, but what does it mean in a formal professional context?
Yeah, that's the perfect place to start. Formally, a risk is an uncertain event or condition that, if it happens, has an impact on your project's objectives.
And that impact can be on anything: your scope, your timeline, your budget, quality, or even the ultimate business benefits you're trying to deliver.
The word that jumps out at me there is uncertainty.
So if I know for a fact that a server is going to fail, that's not a risk, is it?
No, that's a fact. It's a problem you have to solve.
It's an issue.
Precisely. It's the probability that might happen that defines risk. And this leads to, I think, the most crucial distinction that you have to keep in mind. Risks are always about the future. There are things that might happen. The second that uncertain event actually occurs, the vendor confirms they missed the deadline, the server actually goes down, it immediately stops being a risk. It becomes an issue. And an issue has to be managed in real time.
Okay, so risk management is like strategic planning for a potential future, while issue management is basically firefighting in the present.
That's a perfect way to put it. One is proactive anticipation, the other is reactive resolution. They're two completely different muscles.
And we also need to get past this idea that risk is always a bad thing. You mentioned the impact.
Could be positive or negative.
Absolutely. The negative risks are what we call threats. These are the things that, keep project managers up at night.
Sure.
Scope creep, a big delay,
Going over budget, or in the product world, high user churn after you launch something.
But the flip side,
The flip side is opportunities. These are positive risks. Uncertainty can cut both ways. Maybe a new technology lets you deliver way faster than you planned. Or maybe a competitor makes a mistake, and suddenly your market opens up, leading to much higher adoption. If you don't actively look for these opportunities, you can't strategically invest to make them happen. You're just leaving potential wins on the table.
that reframes the entire exercise. It's not just a defensive playbook to avoid failure, it's also an offensive strategy to maximize your gains.
And that strategic mindset is exactly what we see in the most successful product teams today.
Okay, so let's take that strategic mindset and apply it directly to building products.
When a team is trying to figure out what to build next, they aren't thinking in traditional project terms. They're thinking about success in the marketplace. So how does that big abstract definition of risk apply when you're deciding where to invest your engineering time?
This is where the framework from Marty Kagan and the Silicon Valley Product Group, or SVPG, is just so clarifying. Their whole premise is that every investment decision, what you build, what you decide not to build, is fundamentally a risk decision. You're basically making 4 huge assumptions with every feature you plan, and you have to tackle these 4 big risks early in discovery before you write a line of production code.
So what are they? Let's start with what feels like the most important one: value risk.
The value risk is the big one. It's the question: will customers actually buy this, or will users choose to use it? I mean, you can build the most beautiful, technically perfect solution in the world, but if nobody actually
Wants it, you've completely wasted your time.
And what does it look like when that risk becomes an issue? What are the signs?
In the wild, it looks like silence. Nobody clicks on the new button. Your conversion rate is terrible. Or even worse, people try the feature once, it doesn't solve their real problem, and they never come back.
So how do you de-risk that? How do you tackle that uncertainty before you
This is the core of product discovery. You run focused customer interviews to test your hypotheses about even more, and only build it if the demand is real.
I've seen that one. Or concierge test, right?
Yes, the concierge test, where you manually provide the service behind the scenes to prove
The value before you automate anything. All of these things are about proving demand first.
And SVPG is very clear on this. The ownership for this, for making sure you're building the right thing,
That sits with the product manager.
correct. The PM owns the value of the solution, which leads us to the second risk. We've gone from what to build to how people use it. This is risk 2, usability risk. And the question here is, can users actually figure out how to use it? The value might be there, but if the interface is a mess, the value is totally lost.
We've all been there, defeated by a terrible user interface.
Exactly. You see this when users abandon a sign-up form halfway through because it's confusing, or when an app is just unusable on a mobile device.
So if the PM owns the value, it's logical that the ownership of the experience, the usability, falls to the product designer.
It does, and their job is to de-risk the user experience. They do this through usability testing, watching real users interact with the product, and crucially, they build high-fidelity prototypes in tools like Figma. These look and feel like the real thing, so you can
Test the entire user flow without any engineering effort at all. It's incredibly efficient.
Okay, so we've got value and usability. Now we have to actually build it.
Which brings us to risk 3.
feasibility risk. Can our engineers actually build this with the time, skills, and technology we have? This is where ambition meets reality.
I'm thinking of a time when a team thought they could integrate 2 old systems, and then they discovered just how messy it was under the hood.
That is the perfect example. Feasibility risk pops up all the time. You hit unexpected performance limits. You find out your current tech stack just can't support the feature, or an integration with a partner is 10 times harder than you thought.
So the de-risking here is purely technical.
Purely technical. Engineers run technical spikes, which are just small, time-boxed experiments to answer a specific technical question, like, can this database handle the load? They'll also do architecture reviews and build proof of concepts, or PIs, which are
Basically stripped down working versions of the hardest technical part of the problem.
And the owner, for making sure the team isn't promising the impossible, is the lead engineer or tech lead.
Absolutely.
which leaves us with the last and maybe broadest risk. Risk 4, business viability risk. This asks, even if it's valuable, usable, and feasible, does the solution actually work for our business as a whole?
So this is everything outside the product team bubble.
Yeah.
Legal, finance, marketing, sales.
It's all of that. Does it meet legal and compliance standards like GDPR? What's our go-to-market plan? Can we actually afford to acquire customers for this feature? And critically, does it make financial sense? Here's a classic viability trap. You build a feature that's valuable, usable, and feasible, but the transaction fees from your payment provider are so high, they wipe out your profit margin.
So the feature is actually losing you money.
Exactly. It's not viable. The business can't sustain it.
And the ultimate owner for that
Big picture business case, that comes back around to the product manager.
It does. And this is why this SVPG framework is so powerful. When you start to build your risk register, you don't have to argue about who owns what.
If a usability risk comes up, it goes straight to the product designer. A feasibility concern, that's for the tech lead. It provides instant clarity and accountability.
That clarity is amazing, but it's very product focused. Now we need to connect it to the systematic, almost universal process for managing any kind of uncertainty. So let's shift gears and look at the standard PM framework that gives us the structure to manage these 4 risks.
Right? The standard risk management process you'd see in a PMP or Prince 2 certification is a 6-step cycle. It's designed to be repeatable and systematic.
And step 1 is plain risk management. So before we even start looking for risks, we have to agree on the rules of the game. Why is this so important? It feels like something teams would skip.
They do skip it, and it's a huge mistake. Planning risk management is about defining how you're going to do everything that comes next. If you don't agree on the rules, your scoring will be inconsistent, your categories will be a mess.
It's foundational.
So what are you defining here?
You're defining roles, who's in charge of this, you're setting up risk categories, and really importantly, you're setting up the scales for probability and impact.
You have to agree, for instance, what does high impact actually mean? Is it a 4-week delay? A $50,000 cost overrun? You need to quantify it.
And this is where a tool called the risk breakdown structure comes in.
Yes, the RBS. Think of it like a family tree for all your potential risks. The top branches might be things like technical, external, organizational. Then under technical, you might have sub-branches for performance, security, integration.
So it's a checklist, basically.
It's more than that. It's a way to prevent blind spots. If you're brainstorming and you look at your IBS and realize you haven't identified a single risk under, say, regulatory compliance, you know you have a huge gap in your analysis. It forces
systematic coverage.
Okay, so we've got our rules and categories. Step 2, identify risks. This is where we actually start surfacing the threats and opportunities. How do we do this properly?
It has to be a formal effort. You start with workshops and brainstorming, but you have to include stakeholders from outside the core team. You also have to look backward.
Lessons learned from old projects.
Exactly. Use checklists from similar projects. If the last launch was delayed by legal review, that's immediately a high probability risk for this one. And you need to use analysis techniques, things like root cause analysis or a SWOT analysis. And you absolutely must scrutinize all your contracts and dependencies. That's where the skeletons are often buried.
All of this feeds into the risk register. We've called it the single source of truth. Let's get specific. What are the non-negotiable columns that have to be in that document?
Okay, every single risk
Entry needs, at a minimum, a unique ID and a clear description of the risk. It needs a category from your RBS, it needs the scores for probability and impact, and then the 3 most important things:
a planned response, an assigned, accountable risk owner, and a clear trigger.
Let's pause on the trigger. Why is that so important?
Because a trigger makes monitoring objective instead of subjective. Let's say your risk is vendor X might deliver their component late. That's vague. A trigger is component not received by July 15th. Now you have a hard date. If July 15th passes, the trigger is fired, and the risk owner knows they have to execute the response plan. It automates the escalation.
Okay, so now we have a huge list of risks in our register. We can't fix all of them, so step 3. Perform risk analysis. Time to prioritize.
Exactly.
This is all about figuring out how serious each risk is. For most teams, this is qualitative analysis. We use those scales we defined earlier: low, medium, high to rate the probability of it happening and the
Impact if it does.
And this is where we use that classic visual tool, the probability impact matrix.
PI matrix, yes. It's usually a 5x5 grid. You plot probability on one axis, impact on the other. Any risks that land in that top right corner, high probability, high impact, that's your red zone. Those become your top 5 or top 10 lists. They get immediate attention and resources for mitigation.
What about the other corners?
Low, you probably just accept and monitor it. High probability but low impact, you might try to mitigate it. That high corner is where you focus your energy. The matrix makes that prioritization visual and undeniable.
Now, you mentioned that for giant projects, teams sometimes do quantitative analysis, Monte Carlo simulations and things like that. Why do most software teams stick to the qualitative approach?
Because quantitative analysis is incredibly resource intensive. You're assigning specific dollar
values and statistical probabilities to everything. It requires specialized software, a ton of data, and expert analysis. For most product teams, it's just overkill. The
qualitative PI matrix gives you, 90% of the value for 10% of the effort. It's usually more than good enough.
That makes sense. So we've prioritized our top risks. Now we need a plan. Step 4, plan risk responses.
This is the strategy step. And for threats, the negative risks, there are 4 main strategies you need to know. The first and most powerful is avoid. This is where you change your plan to eliminate the risk entirely.
So like dropping a feature because the technology is too risky.
Exactly. Or choosing a different supplier. You alter the plan, so the probability of the risk occurring drops to 0.
But you can't always avoid a risk, especially if it's tied to a core goal.
Right. So the most common strategy is mitigate. This means you take action to reduce either the probability or the impact of the risk. If your risk is poor performance, you mitigate by running technical spikes. That reduces the probability of failure. If the risk is a data breach, you might hire a security firm to do a penetration test. That reduces
the impact if an attack happens. You're spending a little now to avoid a big loss later.
What if we just want someone else to deal with it?
That's transfer. You shift the financial impact of the risk to a third party.
Like buying insurance.
Insurance is a classic example, but it also includes things like strong warranties from vendors or using a reliable SaaS platform instead of building a complex system yourself. You're paying a premium to transfer the consequence.
Okay, so avoid, mitigate, transfer. And the last one is accept. It feels a bit like giving up.
It can, but it's a conscious, strategic decision. Acceptance means you've looked at the cost of the other 3 strategies and decided it's cheaper to just live with the risk. You don't ignore it, you monitor the triggers very closely. And you usually set aside a contingency fund, a budget, or a time buffer, just in case. You're accepting the risk, but you have a fallback plan.
And what about the positive risks, the opportunities?
The strategies are basically mirrors. You can can exploit an opportunity to make sure it happens. You can
Enhance it to increase its positive impact, or you can share it with a partner to maximize the gain.
So we have a plan. Steps 5 and 6 are implement and monitor risks. This is where the rubber meets the road.
How do we make sure these plans actually happen?
This is all about delivery management. Implementation means every single mitigation action becomes a trackable piece of work. It needs an owner, a due date, and it needs to be in your team's workflow, in Jira, or wherever you track tasks. It has to be treated like any other project work.
It consumes team capacity.
Yes, and monitoring is the continuous part of the cycle. You review the risk register regularly, you check the triggers, have any new risks emerged? Has a low-level risk suddenly become more serious? It's a living process, not a one-time document.
Okay, we've gone through that whole systematic process. Now I want to zero in on what is often the biggest single source of risk, especially in big organizations. Dependencies. These are the hidden connections that can bring any project to its knees.
Oh, absolutely. Dependencies are the engines
Of schedule risk. They're the invisible threads that guarantee when one team slips, 5 other teams slip right along with them.
So what's the formal definition?
No, dependency is just a relationship.
where one task relies on another one. The task that's waiting is called the successor, and the task it's waiting on is the predecessor. The successor simply can't start or finish until some condition on the predecessor is met.
Can you give us a really clear modern example?
Sure. Let's say you're building a new mobile app. That's your successor. It needs to get data from a new backend API, which is the predecessor. If the backend team slips their delivery of that API by 1 week, your mobile team is now, by definition, at risk of slipping by at least 1 week. Their fate is tied to the predecessor. That's a dependency risk.
And there are different types of these relationships which dictate how the schedule actually works.
That's right. There are 4 logical types, and you really need to understand them. The first
And most common is finish to start, or FS. This is a hard handoff. The successor cannot start until the predecessor is 100% finished.
Like, you
Can't
can't
start painting a house until the construction is finished.
perfect example. The second is start to start, or SS. This allows for parallel work. The successor can't start until the predecessor has started. For example, your QA team can start writing test cases as soon as the development team has started coding. They don't need to wait for the code to be finished.
Got it. And the third,
Finish to finish, or FF. The successor can't finish until the predecessor is finished. Think about project documentation. The writers can work in parallel, but they can't finalize and publish the manual until the software itself is completely done and locked.
okay, and the last one is pretty rare.
Very rare. Start to finish, SF. The successor can't finish until the predecessor starts. The classic example is a system handoff. The old support team can't stand down and finish their work until the new support team has started theirs to ensure
There's no gap in coverage.
Beyond the logic, there's another crucial way to categorize dependencies: internal versus external. Why is an external dependency so much riskier?
control. It all comes down to control. Internal dependencies are between your own teams. It might be messy to coordinate, but at the end of the day, you can escalate, reprioritize, and solve it internally.
You're all on the same team.
Right. But external dependencies rely on third parties, vendors, partners, government regulators. You have almost no control over their schedules, their quality, or their priorities. If your launch depends on a component from a supplier and their factory has a problem, there's very little you can do besides wait. That lack of control is why external dependencies should always be treated as high priority risks that need a very robust mitigation or contingency plan.
That makes so much sense. The level of control you have really dictates what your response
Strategy can't even be.
So we have all these complex links and relationships. How do we make sense of them all? How do we make them visible? We use a dependency map.
What exactly is a
dependency map. How is it different from just looking at a Gantt chart?
A dependency map is a visual representation of how all the pieces of work rely on each other. A Gantt chart is really focused on a linear timeline of individual tasks. A map focuses on the connections and the handoffs between teams. It turns a complex spreadsheet into a simple story. Who is waiting on whom?
What are the key elements on one of these maps?
It's pretty simple. You have nodes, which are boxes representing the big pieces of work. You have arrows showing the direction of the dependency from the predecessor to the successor. And then you have annotations with the important details, like the dependency type FS, SS, and the committed due dates. You can also color code them to highlight the really high-risk ones, like making all external dependencies red.
Okay, but if all those links are already tracked in a tool like Jira, why take the time to draw this map? What's the real benefit?
Because the
Software tools are terrible at showing the big picture, the chain reaction. A visual map gives you immediate insights. First, it surfaces your bottlenecks and your single points of failure.
If you draw the map and see 10 arrows all pointing from one small team, you've just found your project's biggest risk. That one team is gating everyone else.
Right, it becomes instantly obvious.
Second, it makes your schedule much more realistic. Teams often forget to factor in the waiting time. The map forces you to confront the real critical path. And finally, it's a direct input for your risk register. Every critical link on that map, especially the external ones, becomes a candidate for a formal risk mitigation plan.
This sounds incredibly powerful. If someone listening wants to build one of these, what are the steps?
It's a pretty straightforward 6-step process. Step 1, list your work items, pull together your roadmap,
Your key epics, everything you plan to deliver in the next quarter or so. Step 2, identify the dependencies. For every single item on that list, you have to ask, what needs to be done
before we can start this, what do we need before we can finish it? Step 3, categorize them. Is it an FS, SS, or FF? Is it internal or external? And give it an initial risk rating, high, medium, or low.
And then step 4 is the drawing part.
Step 4, draw the map. You can use a whiteboard, a digital tool, whatever works. Start with the earliest tasks and draw the arrows to show the flow of work towards your final goal.
Okay, now for what sounds like the most important step. Validate it in a workshop. Why is this so critical?
Because a map is just a theory until everyone agrees on it. You have to get the givers, the teams providing the dependency, and the receivers, the teams consuming it, in the same room. And you use the map to force the conversation. Team A, you were saying you need this API from Team B by June 1st. Team B, can you actually commit to that date? This workshop is where you turn assumptions into commitments. If there's a mismatch,
that's a high priority risk you have to solve right now.
And the final step is just keeping it alive.
Step 6, maintain it. The map has to be a living document.
You review it every week or at the start of every sprint. When scope changes, the map has to change. An out-of-date dependency map is worse than no map at all.
And this is where it all comes together. We have the systematic PMI process, we have the SVPG ownership model, and we have this powerful tool of dependency mapping. Let's walk through how we merge all of this to build a practical top 5 risk list for a real-world scenario.
Right, the dependency map is what feeds the risk register. The map shows you the biggest threats to your timeline, and then you formalize them, give them an owner, and create a response plan. For example, the map might show that you're relying on a team that's always overloaded, so your risk description becomes really specific. The platform team may delay our environment setup by 2 weeks, which will delay our entire testing phase.
So it forces you to move from just padding your schedule to creating a targeted mitigation plan.
Precisely.
And it helps you identify where a small investment can save you from a huge delay. The map might show a risky third-party dependency. So your mitigation could be to build a
temporary mock version of their API so your team can start development in parallel instead of just waiting.
Okay, let's run through the full case study. We're launching a brand new online payments feature. Let's build the top 5 risk list using the SVPG categories.
Great, this shows the whole picture. Risk number 1 is value risk. The threat is that customers just don't adopt the new payment method, and all that effort is wasted. The owner is, of course, the product manager.
And the mitigation has to be cheap and fast validation.
Exactly. The plan is run discovery interviews to confirm the need, then launch the feature as an A/B test against the old payment flow to measure the real conversion rate, and start with a very small controlled beta group to see if there are any major drop-offs. Fail fast if the data is bad. Risk number 2, usability risk. The threat, users on mobile devices find the new flow confusing and abandon their carts. The owner is the product designer or UX lead, so the mitigation is all
about testing the experience. The designer builds a clickable prototype and tests it with at least 8 to 10 real users on their phones. They also have to enforce very strict design standards for error messages and accessibility on small screens.
Next up, risk 3, feasibility risk. The threat here is that engineering can't meet a strict performance requirement, like a sub-2-second response time, because they're integrating with some old, slow legacy systems. The owner is the lead engineer.
So the lead engineer has to tackle that technical uncertainty head-on. The mitigation is to run a technical spike immediately to test the performance under load. They bring in the architecture team early to design solutions like caching. And if that spike fails to meet the performance target, that's the trigger to pivot the response to either reducing scope or finding a completely different technical approach. Risk number 4, business viability risk. The threat. The transaction fees from the new payment provider plus the extra support costs are
So high that they actually destroy our profit margin. The owner here is the product manager working hand in hand with finance.
So this is moving way beyond just the tech.
This is pure business modeling. The mitigation is to work with the finance team to model different scenarios. You negotiate hard with the payment providers, and you have to explore different pricing options, which might even include passing some of those fees on to the customer to keep the feature viable. And finally, integrating our schedule risk. Risk number 5, a dependency or external risk, the threat. Our launch depends entirely on a third-party, know-your-customer provider finishing their API integration on time, and we can't control them.
So the owner is probably a delivery manager or program manager. And since we have no control, the mitigation has to be all about visibility and contingency.
That's the perfect
Transforming itself strategy. Your mitigation is twofold. First, maximum visibility. You put their key milestones directly on your dependency map and you have mandatory weekly check-ins. Second, you build a fallback plan. Maybe you create a temporary manual KYC process for the first handful of customers. It's more expensive operationally in the short term, but it protects your launch date from a total slip.
That complete list is just. It's the definition of proactive management. You've covered every angle, the market, the experience, the tech, the finances, and the schedule. And every single one has a clear owner and a trackable action.
And that top 5 list is now ready to be scored, tracked, and managed in your risk register, visible to everyone.
We have covered a huge amount of ground today. We've gone from the very definition of uncertainty all the way to a tactical 5-point risk plan. Let's distill this down to the key takeaways for you, the learner.
Okay,
Takeaway 1. Internalize the difference between a future risk and a current issue. One is for proactive planning, the other is for reactive firefighting. Don't mix them up.
Second,
Burn that SVPG ownership model into your brain. Value and viability belong to the product manager. Usability belongs to the designer. And feasibility belongs to the engineer. If you can categorize the risk, you instantly know who owns it.
third, the risk register is your single source of truth. If a risk doesn't have a description, a score, a trigger, and an owner, it's not being managed, it's just a worry.
And finally, remember that dependency mapping is your best friend for uncovering schedule risk. Making the invisible visible, seeing who is waiting on whom, is the first step to preventing catastrophic delays. We also want to leave you with a few really critical tips, the kind of things that separate the theory from what high-performing teams actually do.
Tip 1. Always assign a risk owner. An unowned risk is a guarantee of a future issue. Accountability is everything. Tip 2. When you're mapping dependencies, be ruthless.
Is it a true dependency where A must be done before B, or is it just a preference? Filling your map with false dependencies creates noise and kills focus. And tip 3, and this is so important,
Integrate your mitigation tasks directly into your team's daily workflow. If it's not a Jira ticket, if it's not being talked about in stand-up, it's not going to get done.
At the end of the day, this entire conversation about risk isn't about being pessimistic. It's about being a realist. It's about optimizing your future outcomes by forcing absolute clarity and ownership into your plan today.
So as you go into your week, ask yourself this. What critical dependency or major risk are you and your team currently accepting just because it's always been that way? And how quickly can you convert that vague uncertainty into a specific owned mitigation task that gets tracked against your team's progress this week?
Until